what we're having a look at is our proportionality theorem. All right, so some of you may have had a look at this in grade 10. Some of you may not have. It's very much dependent on your school. Some schools do teach the midpoint theorem and the proportionality theorem in grade 10 and then only touch it again in matric. Some schools choose not to do it all until matric. So it's very much dependent on your school, obviously. And I can say some of you might be familiar with it, some of you maybe not. That's fine. We're starting from the basics in any case. So if you're not super familiar, don't stress. Okay, so the proportionality theorem states that a line drawn parallel to one side of a triangle cuts the other sides proportionally. And we could be even more specific, cuts the other two sides proportionally. So if you have a look at this little diagram that I've got here, we have got essentially exactly that. So looking at the diagram that I've given you guys, you've been given triangle ABC, big triangle, and you have been told that PC is parallel to BC. So that's what we give you, a line drawn parallel to one side. Those are the two lines. The one side of my triangle in this case is BC, and we have drawn in the line PQ. So if you've got that, if you've got two parallel lines in your triangle, one of them being one of the sides of your triangle, what you are then able to say is that your is that the two sides that the line you've drawn go through, they are cut proportionally. I feel like my English there was a little dodgy, so I'll try that again. So this line PQ cuts the side AB at P and cuts the side AC at Q, but it cuts it in proportion. So what we mean by that is that whatever the ratio of AP to PB is exactly the same as the ratio from AQ to QC. Now, importantly, I'm using the word ratio. I'm not saying they are the same length. I'm saying they are in proportion. So for example, if this was, I'm just going to make this up, if this was 20 centimeters and that was 10 centimeters, that ratio is 2:1. AP is double the length of PB, which means that AQ could be 60 and QC 30. It is in proportion. They are both double the length, or they have a proportion or a ratio of 2:1. And that's what this little pink block is saying here. They are in proportion to each other. So once again, they're not the same length, they're in proportion. And I think this is where maybe the theorem gets a bit confusing with ratios and with lengths and knowing what's what. So we're going to work through all of those situations. So again, when you've got a line drawn parallel to one side of your triangle, the two sides that that line cuts, it cuts it in proportion. That proportion could be anything, and we'll start chatting about those things now, but it cuts it in proportion, so the ratio of one side to the next will be exactly the same on the corresponding other side of your triangle. Now, obviously, this is geometry, so we always have to give a reason for any statement that we make. There's two reasons that you can give here. Either you can use, okay, proportional intercept theorem is very, very long. We don't need to use that. So the shortened version of this is just prop theorem. And remember, theorem you can abbreviate to THM. And then you would state your parallel lines. I don't know why I said R. Let's try that again. PQ is parallel to BC. So that's your option one, prop theorem. And then you state your parallel lines. Option two is just saying line parallel to one side of triangle. You do you. Okay, at the end of the day, whichever one makes more sense for you. I feel like I use prop theorem a lot. I'm now questioning myself because I go between the two. I feel like I use prop theorem most, but if you say line parallel to one side of triangle, absolutely fine. So either of those two reasons, perfectly acceptable, whichever one works best for you. All right, so that is our proportion theorem. Now, the midpoint theorem, which some of you might have learned in grade 10, is essentially an extension of this. The midpoint theorem states essentially that a line drawn parallel to one side of the triangle and equal to half the length of that side it's parallel to cuts the other two sides exactly in half. That's what the midpoint theorem states. So the midpoint theorem is basically the proportion theorem in extension. And so again, midpoint theorem is actually part of the grade 10 syllabus, so most of you would have learned it in grade 10, but if you haven't, just a little reminder. All right, so we will, like I say, work through all of this, look at the basics, work to more complex. But midpoint theorem is something that you've learned, is something that extends from this proportion theorem. So just as a link, as a reminder for you. Now, there is a proof for this theorem, same as any other geometry proof. Sorry, guys. I'm not going to go through the proof just for sake of time. It's also one of those things, the same as, like I said, with circle geometry. It's either something you learn or either something you don't learn. That's a choice you're going to make. You're either choosing to make sure that you get those 5 marks, or you're sacrificing those 5 marks and you're making very, very sure that you get them somewhere else. So that is your choice. I have put the theorem proof on Google Classroom so that you guys can go and have a look at how the theorem is proved. This theorem, and again, I'm saying it, but it could change. I have never seen the proportion theorem asked. Usually it is a circle theorem that's asked, and it's usually actually the tan chord theorem. It's not to say that it can't be any of the other theorems. That's not the case, but it is usually one of your circle theorems that is examined in grade 12. Again, I am not saying by any means that it is impossible to have the proportionality theorem as your proof question. I've just never seen it asked, at least not in the last, 6 years. Right. So again, not to say they can't ask you. I just haven't seen it asked regularly. It is more often a circle theorem proof. And as you go through your past papers, you'll start to see that. And like I say, guys, that is a guaranteed question. You're going to get a proof question. And so that's what I'm saying to you. Either know your proofs and you bank those marks, or you make very sure you're going to get them somewhere else. All right, so I'll quickly wait here in case you want to take a screenshot of the theorem. Otherwise, we're going to move straight into some examples. So just so that you kind of know where we're going, we're going to use the basics today of proportion and the basics today on Wednesday of similarity. And then next week, we're going to start to add complexity, sort of look at combining those two, because that's often how it's tested, proportion and similarity together, and start working through some past paper questions. Okay, so just so you know where we're going, we are doing basics this week, but we are going to step it up to the level at which you need to know it next week. Okay, the sun is very bright. Right, first example. So example 1, again, nice and basic, nothing we're going to stress about, is just understanding how these ratios and these proportions work. Sorry, guys, I just want to have a little cough. Okay, so it's just understanding how the ratios and the proportions work. Now, the reason for this, and it might seem really silly, and that's okay if you think it's a silly example, cool. But the reason for this example is because you need to understand that there's many different ways that we can combine ratios. But what's important is that you keep it consistent and you keep the sides corresponding with each other. So for example, in the first question, we have got PY, which if we go and have a look at our triangle, is this line segment over here, divided by YR. And so this would be the line segment over here. If we want to say what is in proportion to it, we now go and have a look on the other side of my triangle, because I've got that parallel line XY. XY is parallel to QR. I know that on the other side, it's being cut in proportion. So PY corresponds to PX. So in my little ratio here, I can write PX. YR corresponds to XQ. And so in my little ratio here, I can write XQ. So that's just one example of one of the ratios I could write down for this triangle. The top 2 segments in relation to the bottom 2 segments. Perfect, no problem. If I go and have a look at my next one, and I'll get you to do some of these by yourself. I don't think I need to do all of them. If we look at the next one, we've got QX. So QX is this blue segment on the side over XP. Now, if you have a look, this actually looks very, very similar to what we've just done. It's the same 2 line segments that I'm highlighting, but do you notice how I highlighted the bottom line segment first and then the top line segment? So if we go to our numerator QX, that corresponds to YR. So in my ratio, I can write YR. If I go look at XP, XP corresponds to PY. And so again, in my ratio, I can now write it in my denominator, PY. So these two are very, very similar to each other. We've just swapped them. There's nothing wrong with that. Okay, the ratio is still consistent. And that's why I said earlier, there's so many different ways you can set up these ratios. And really, you're going to set it up depending on the question. What's really important is that you're consistent. Like in this case, I compared bottom line segment to top line segment. That must be the case in both of the ratios I'm working with. I can't just chop and change what I'm choosing to work with. Keep it consistent and you will be fine. Okay. So if we have a look then at this next row down, we've got PY, which is this line segment here. And now we just need to be careful. The next one that we've been given is PR. Now, PR is quite literally the whole side of my triangle. So this is another way we can set up a ratio. I don't just have to work with the little line segments of my triangle. I can use an entire length and then part of the line, which is absolutely fine. So my numerator was PY. That corresponds to PX. So in my numerator, I'll have PX. Sorry. And then the whole side PR obviously will correspond on the other side with the whole side PQ. And so this is over PQ. And so once again, how you set up your ratio, you do you. It's going to depend on the question and what you're trying to find. But just bear in mind that there are different ways to set up these ratios. All right, guys, so I'm going to give you 2 minutes. I want you to try these last two for me, and then hopefully someone will be brave enough to give me an answer. But I'll give you 2 minutes to try and complete those ratios first, and then we'll have a look at some answers. And like I said, if you're feeling brave, be ready to unmute yourself and give me the ratio. Remember, you're also more than welcome to put answers in the chat if you want to. You don't have to. I'm going to ask, like I say, in 2 minutes, but you are more than welcome to. Okay, let's have a look. Does anyone want to give me the ratio that will correspond with PQ over XQ? You're welcome to unmute yourself. I do have some answers on the chat, which are awesome. And so...
Hi, ma'am.
Hi. Wait, who's talking? Hang on. Too much? Yes?
Ma'am, can I answer the thing PQ, ma'am?
Yeah. Cool. I'm ready. This one over here, the PQ over XQ.
Yes, ma'am. So I said PQ, I said PR over PY.
Am I on the right one? Are we talking about this block over here? Or the
Yes,
other one?
No, this one.
Okay, sorry. Okay, sorry. I just was losing that. Cool. Thank you. Okay, so cool. PR, and then you gave me PY. Let's just double check. So PQ is the whole length. Sorry, 100% agree with the PR. Awesome. And then XQ is this little line segment here. So what corresponds with xq?
Oh, YR, man, sorry.
Perfect. Okay, apparently I can't write YR, so I'm just going to write it over here. Apparently I can't do that either. Okay, so PR over YR. Excellent. Well done. Thank you so much. Okay, and again, an example of how, excuse me, you can use the entire side length. Okay, anyone want to give me the next one? This one's a little... Anyone?
Hi, ma'am.
Hi.
I said PQ over PX equals PR over PY.
Very nice. Excellent. Okay, so guys, let's just chat about why that's the case. So PQ is the whole length. So Nam just said that that would correspond to PR. That makes sense. The whole length on the other side is PR. Whoops. Would put it in the right place. So our numerators are the whole side lengths. And then in my denominator, I'm having a look at PY. So PY is this top line segment. So on the other side, that would be PX. And so exactly, this would now be over PX. So really, really importantly, again, is that you need to remember that, like I say, you can set up these ratios in any way, and it's going to be very much dependent on the question. But remember that it can be essentially any part of that line. You can flip the fractions, it can be the whole side length, it can be a segment, it can be any part. Just keep it consistent. Okay, so if you want to screenshot this first example, do it now, but otherwise we're going to now take this and actually put it into practice when using the triangles and looking to find unknown lengths. Okay. Right, so this is example 2. I've given us some information. So we have been told in the diagram below, AB is equal to 12 centimeters, FB is equal to 3 centimeters, and GC is equal to 14 centimeters. Calculate the length of AG. So there's no information on my diagram, so I'm just going to put some information on my diagram so that I know what's going on. AB, which is this whole length here, is 12 centimeters. FB, so this little line segment down here, and I'm actually not going to use an arrow, I'm just going to do this. It's 3 centimeters. And GC, so on the other side, is 14 centimeters. So again, do you see those lengths, FB corresponding with GC, are not the same, but they should be in proportion because that line, FG, cool, the line FG is parallel to the side of the triangle BC. I have been asked to find the length of AG. So I'm looking for this length that I'm highlighting very badly in red over there. Now, guys, remember, geometry is a write-on answer book. So you will get an answer book with all of the diagrams reprinted in your answer book. Highlight, color in, draw on, do what you need to do for geometry. So for me, it's very helpful to highlight. It's very helpful to write things on. I just find it a lot easier to deal with. If that works for you, do it. Okay, so we're looking for AG, and we now need to look at what information we've been given. Now, the really important bit of information that we've been given are these parallel lines. Because I've got those parallel lines, I know that I can set up ratios or proportions of my sides that are equal. Now, obviously, because there's so many possibilities, we now need to decide which possibility makes the most sense. Now, in order to do that, I would start in my very first fractions numerator with the side I want. So I want AG. So that's what I'm going to start with. I'm going to start with AG over. Now, AG is on the side length AC. I'm going to have a look at that and decide what information do I already know on that side length. Well, the piece of information I already know is that GC is 14 centimeters. So I'm going to put this over GC. Apparently, I'm not. Let's try again. I don't know where it wants me to write. Okay. AG over AC. And now I set up my proportion accordingly. So again, how I decide to do this. In my numerator of my first fraction, I write down the thing that I want. If I need to do some other working out, I can do that, but I write down the side that I'm looking for. Then I have a look at to see in my denominator, I want information that I have, whether it's the whole side length, whether it's a line segment like I have here for GC. You decide, you have a look and see what information do you have and what information can you substitute in. Now, the reason I'm saying pick what you know is because remember, our goal is to solve for AG. I don't want a whole bunch of unknowns. That's not going to help me. If I can try and get everything to be known to me, I'm sorted. Right, so AG corresponds with AF, and we'll chat about that in a second, and GC corresponds with FB. So I've set up my ratio. I know this is true because of those parallel lines. I obviously just need my reason. So either it's line parallel to one side of triangle or prop theorem, and you state your parallel line. So for prop theorem, you have to state the parallel lines. FG parallel to BC. Obviously, if you did it the other way around, that's fine. Okay, so we've got our prop theorem, we've got our proportion set up. Now that I've got that, I can start substituting in what I know. Now, just be mindful of the fact that we don't actually know the length of AF. So AF is this blue one here, but because I've got the whole line segment AB, and I know this little section down here is 3, I can very easily go work out what I'm missing. So 12 minus 3 gives me 9, and so AF is equal to 9 centimeters. Obviously, if you want to write that down and say AF is equal to 12 minus 3, so that's 9 centimeters, go for it. And remember, we always say treat geometry and the person marking your geometry as if they know nothing. I know nothing about geometry. I need to follow exactly what you've done. So when in doubt, write it down. Something like this, we kind of assume that you can just subtract or add or whatever you need to do. But again, when in doubt, write it down. So now I've got all my information I'm going to substitute in. So AG, what I'm looking for, over AC. Now AC's length, what am I doing? GC, goodness gracious. AG over GC's length, which is 14. Oh, guys, sorry, I don't know why my pen's been super difficult of late. Let's move this up a touch and hopefully we'll get there. So AG over GC, which is 14, is equal to AF. We've just worked out AF, 9 over FB, which is 3. That was all information given to me. I haven't made up those numbers. Those numbers have all come from the information given to me in my question. And now I can go and solve. So just through basic inverse operations, AG is going to be equal to 9 over 3 times 14. We don't expect you to do this without a calculator. Please use a calculator. Like, no one wants to sit and multiply fractions unnecessarily. So we'll multiply 9 over 3 by 14, and we get the length of our side. So anyone want to tell me what is 9 over 3 times 14? Nice, guys, 42 centimeters. Okay, good. Now, remember, the ratio should be consistent, or it should be in proportion. So if we, for example, look at the blue, beautiful highlighting I've got there, and I take AF over FB. This was 9:3, so that's a ratio of 3. If we now do exactly the same thing, so AF corresponds to AG, and FB to GC. We've just worked out AG to be 42, GC is 14, and hopefully, if math serves me correctly, 42 divided by 14 is 3. That proportion is exactly the same, and that's what the proportion theorem says to us. Okay, so when looking for these unknown side lengths, start in your first numerator by writing down the line segment you want, and then start filling in the information that you have using the correct proportions. Right, that's just going to be the easiest way to get it. There's lots of different ways you could have set up this ratio, lots of different ways. But this is using everything that you know and putting your unknown in the numerator. If your unknown's in the denominator, it makes it more complicated to solve. I'm not saying it's wrong. It does just make it harder to solve. Right, so let's take a screenshot here, and then let's have a look at example 3. And remember, guys, if you've got questions as I'm going along, please ask. I know this is not, I mean, for me, I hate this part of geometry, but I know this is not everyone's favorite section. And so we just need to ask questions and make sure that we are happy with what's going on. Okay. So let's have a look at example 3. Sorry if you can hear the cheering. Okay, there's a question. Would you get marked down if you didn't write the centimeters? No. I'm just pedantic about it. So it's fine. If you just said AG equals 42, that's absolutely fine. I always put my units in. It's just something I don't know where this obsession with units has come from, but it's fine. 42, you're not going to be marked down if you leave your units out. Okay, we're not that strict when it comes to the maths, or comes to maths with units. Okay. So example 3 says in triangle ACE, so triangle ACE is this big triangle, BD is parallel to AE. Now, I've said this before when we did our circle geometry. I like to highlight the things I know are true. So BD is parallel to AE. Again, this is just a visual aid for myself. It helps me. If it doesn't help you, you don't do it. Calculate the value of y. So if we look at where y is a line segment AB. And now we need to go and have a look at what information we've been given. So we have been given the length of AC, 35 centimeters. We've been given the length of CD and of DE, which technically means I have the length of CE. I'll just add them together. And we're looking for y. So again, the way we're going to do this is we're going to set it up with my first fractions numerator containing the value I want. So y, let's not do that. So that would be AB. Now we start setting up our ratio, and we go to the side that contains AB and we look at what information we have. I know the whole length of that side AC, so I'm going to put this over. Oh, why do you hate me? I'm going to put this over AC. And now I have to set up my proportion is equal to, so AB corresponds to DE, and the whole side AC corresponds to the whole side CE. What I've done is I've used all of the information I know because it's easy to then substitute in.
Hi, ma'am.
Obviously, I have to give a read. Oh, hello. Sorry.
Why can't we say that AC corresponds with AE, ma'am?
AC corresponds with AE. Okay, so good question. I'm just going to grab a highlighter here. So the question is, why can't we say that this AC corresponds with AE? Now, just be careful. We need to be using our parallel lines. So the parallel lines is sort of guiding me to which side I should be using. AE is not being cut by one of those parallel lines. So if I just go back up to the theorem, the parallel line and then the proportions that I work with are based on the sides that are being cut by that parallel line. This third side is just the line it's parallel to. It doesn't actually feature in any of my ratios because it's not being cut in proportion with my ratio or by my parallel line. And so here, because AE is not being cut in proportion, we're not going to set up, or we're not going to use it to set up any of our proportions. It is actually only AC and CE that are being cut by the parallel lines and so being cut up in proportion. Does that make sense?
Yes, ma'am.
Okay, good. Okay, guys, really good question. That's really something that we need to take note of. We need to be mindful of which sides we're working with, and we're working with the two sides that are being essentially by the parallel line that's drawn in your triangle. Okay, I was going to say something else, but now it's gone out of my head, so it can't have been important. Cool. We need to give our reason, prop theorem or line parallel to one side of triangle. I just find that reason quite wordy, so I use prop theorem. And then just remember to state your parallel lines, AE parallel to BD. Now we start subbing in what we know. So AB is at Y. AC we were given as 35 centimeters. DE we know is 18. And remember I said to you this length CE is just found by saying 24 plus 18. You've got the two line segments, just add them together. So that is going to give you 42. And just correct my maths if you don't agree with me. I did that quickly in my head. Anything's possible. Okay, so we get it over 42, and now we solve for y. So I'll give you 30 seconds, and then hopefully someone can tell me what y is equal to. And put it in the chat. You're also welcome to just unmute yourself. Nice, guys. Nice. Amazing, grade 12. Well done. Okay, so it's equal to 15. Again, I'm just pedantic, so it's equal to 15 centimeters. If you just said 15, that's absolutely fine. Okay, we're not going to take marks off if you left out a unit. Good, guys. Okay, so you've got one that you're going to try by yourselves now. I'll wait here for 2 seconds in case you want a screenshot. And then we'll have a look, or you will have a look at the you try question. Okay. Right, so here's your you try. As you can see, it's actually quite a short little solution. It's my purple little blocky. We are determining the value of x. Don't overthink it. Don't overcomplicate it. Let's see what we get for our... Oh, someone's having a field day on my screen. I don't know who you are. Can I see who's... If you could take your scribbles off my screen, that'd be grand. Thank you. Okay, guys, let's give this one a try. I don't think you need too long, so I'm going to give you 3 minutes and then we'll see. Remember, feel free to put answers in the chat if you want. Okay, guys, let's have a look. All right, so you've been given PQ is perpendicular to BC, so that's great. And like I say, this now helps us because we know that to set up our proportion, we need to be using the sides cut by the parallel line. So it would be AB and AC. Those are the sides we're going to use to set up our proportion. We're looking for X, so that will go in the numerator of our first fraction. And X is the side QC, so that corresponds with PB. And then the other bit of information that we have is AQ and AP. Now, again, you could use the whole length AB and the whole length AC, but you're making it more complicated. I'll explain why in a second, but use the information you have. Right, so if we have a look, this is essentially all we need to do. We set up our ratio. So exactly as I just explained it, QC, which is that X over AQ, is equal to PB over AP. We substitute in the information that we know, and then we solve. Just so we're all clear, what I did here is I said X is equal to 3 over 5 times 4, because remember, to get rid of that denominator, we will multiply both sides by 4, and that gave me the 2,4. There's nothing wrong with the decimal. Okay, remember, lengths are measured with decimals, so there's absolutely there's absolutely nothing wrong with a decimal. Okay, now just for argument's sake, if you had said QC over the whole length AC, that would correspond with QC, which is still PB or BP, over the whole length AB. Now, what you need to remember is that for AC, the whole length is 4 plus X. So this would now become X over X plus 4 is equal to PB, which is 3, over AP, which is 8. There is nothing wrong with that. The reason I'm saying is avoid it is because what you should notice is that now you've got an X unknown in both your numerator and your denominator. And so you're just overcomplicating an otherwise simple situation. There's nothing wrong with doing it like this. So if that's how you set up your ratio, by all means, go for it. But try and work with the information that you already have without needing to manipulate more or find out more. So yeah, nothing wrong with this, but it's not the easiest way to get your answer. Okay, let's take a screenshot and then let's have a look at, what are we? Example 4. Okay, so remember, we will do more complex questions from Monday next week. And the next couple are slightly more complex, especially when it comes to the algebra. So don't think that it'll always just be as straightforward as this. It won't necessarily. But once we've done the basics of proportion and similarity, we can start looking at the more complex stuff. Right. So if we have a look at example 4, this is now what I was saying in terms of these questions can get more challenging in terms of algebra. So we've been told triangle DEF, which is this bad boy over here. Obviously, I can't highlight a triangle, but whatever. In triangle DEF, GH is parallel to EF. Okay, so those are my parallel lines I've been given, which allows me to identify which sides I'm working with for my proportion. I've been asked to calculate the value of M. Now, if you have a look, M is on 2 sides of my triangle. I've got an M plus 2 on the right here, whatever, and I've got an M on the left. Highlighting is not doing it today. So now we need to be careful. When you've got these unknowns on 2 sides of your triangle, my advice again is to try and keep the unknown in the numerator. So what I see is that in both cases, my unknown is corresponding with the top segment on each side that is cut or split proportionally. So that's what I'm going to do. So I'm going to go DG over, and we'll decide what it should be over now, is equal to, and DG corresponds to DH. So DH over, and we'll decide. So now I look at my triangles and I see that in both cases, I've been given the bottom segment. So that's perfect. I'm going to go DG over GE. Over GE is equal to DH over that bottom segment on the right, HF. This is all because of my prop theorem. And remember to state your parallel lines, GH parallel to EF. Sorted. Now I can go and substitute in what I know. So DG was M, GE was 2, DH was M plus 2, and HF was 3. I can solve my equation. Okay, now guys, there's a few different ways that you can approach this next step. Because it's one fraction on either side of my equal sign, I would just cross multiply. So that means I'm going to take the 2 and multiply it with the M plus 2. And then I'm going to take the 3 and multiply it with the M. If you cross multiply, essentially you're getting rid of those denominators. It's basically a shortcut of finding an LCD, which is what you would do anyways. So this gives me 3M is equal to 2 times M plus 2. We'll obviously distribute that bracket, giving me 2M plus 4. And combining my like terms, I've got 3M minus 2M is equal to 4, which means M is equal to 4. And in this case, there's no units, so you can just say 4. If you wanted to say units, that's absolutely fine as well. But as I said earlier, you can just leave it at, oops, sorry. You can just leave it at 4. Okay, now sometimes these algebraic expressions or these algebraic questions can end up in a quadratic. I set a test this year where I know there was a quadratic. So what I'll do is when we get to those more complex questions, we'll have a look at that exact question. So they can become more complicated than this, but the key is start with what you don't know in your numerator. In this case, yes, both of my numerators contained an unknown, but it was in my numerator. Makes the solving so much easier to do. Okay. Right, so again, screenshots, and please, if you've got questions, just ask. I'm not seeing anything in the chat, but just ask as you go along if you've got questions while I'm doing anything. Okay, let's have a look at example 5. Whoops, sorry. Okay, so example 5 is an example that I quite enjoy because there's 2 triangles here. We've got 2 sets of parallel lines. We need to be careful. So if we just read our question, in triangle ACF, so that is this blue triangle over here. Oh, okay. Okay, whatever. In this triangle, we're just going to roll with it. We have been told that AF is parallel to BG. So, I feel like I'm just not coping today. AF is parallel to BG. And then in my second triangle, CEF, so this purple triangle down here, I've also been told that EF is parallel to DG. So EF parallel to DG. Cool. We've then been given a bunch of other information, which I'm going to fill in on my diagram because that's obviously not been given to me on the diagram, and it would be helpful if it was. ED, so the segment down here is 22 centimeters. DC, the segment next to it is 33 centimeters. BC, here on the right, is 15. And AB is X. And what do you know? The question is asking us to calculate the value of X. So I'm looking for this line segment's length, AB. All right. So what we see is that that line segment is in my blue triangle that I've drawn there. I can't set up a proportion because I don't have enough information. I have no idea what FG or GC are, so I can't set up a proportion there. And so that makes it a little trickier for me to go and find, oh, why do you hate me? For me to go and find what X is. But because I've got 2 triangles, the second I see 2 triangles connected with parallel lines, automatically we need to be thinking, okay, cool. I'm going to have to set up a proportion in my first triangle, and that will then lead me into my second triangle. And so that's exactly what we need to do. So we know because of those purple parallel lines, EF and DG, that ED is in proportion to FG and that DC is in proportion to GC. So I can make that statement. So I know that ED over ED over DC is equal to FG over GC. I know that's true because of my parallel lines and my prop theorem. And we state those parallel lines, EF parallel to D, oops, I don't know, G. Now, because that's true, whatever the ratio of ED to DC is going to be the exact same ratio for FG to GC. Now, ED was 22 centimeters and DC was 33, which means the ratio that we have here that corresponds to FG, if we go and simplify that, is a 2:3 ratio. Right, so what that means is that 2 parts here represent or is in proportion to the 3 parts in the bottom segment. It's not a length. I'm not saying that FG is 2 centimeters and GC is 3. I'm saying it's a ratio, this many parts to this many parts. But now that we have this ratio, what we can now do is we can now apply it to my blue triangle, because what we see is that whatever FG is corresponds to AB, and the ratio for GC corresponds to BC. And so now I can set up that ratio for myself. So I know that FG over GC, come on. Let's try here. No. FG over GC corresponds to, and if you follow the blue arrows, AB over BC. And that all corresponds to that ratio of 2/3. Again, this is because of my prop theorem. And again, I know I got 2/3 because I had to do some working out beforehand. AF parallel to BG. And now that I've got this information, I can now go and work out my missing value of X. Right, so I want you guys to finish it off for me, work out what X is. Oh, golly. Right, I'll give you 2-3 minutes and then we'll go and see if we agree. She could on it. Some of you are on it. Which is awesome. Like I said, I'll give you 2-3 minutes and then we'll have a look. So figure out or finish off working out what AB or X is. Okay, guys, so if we have a look, I see some answers coming through, which is awesome. We already know that FG to GC is this ratio 2/3. There was a reason why we went and found that. So we've got 2/3 is equal to X, because that's AB over 15. And so to get X alone, we would have to say 2/3 times 15. And so that gives me that X is equal to 10 centimeters. Again, if you just say 10, it's fine. It's not the end of the world. But we get 10 centimeters. Right, so this question, what we need to bear in mind is that sometimes, and quite honestly often, we need to do a bit of work first before we can get to the actual final answer that we're looking for. And there's nothing wrong with that. This is also training us or also showing us that a ratio set up or proportion set up in one triangle can be used in another triangle. And that's going to be a really important concept to understand as we move forward with this geometry section. All right, so take your screenshots. Oops, sorry. Once you've done that, if you guys don't have any questions, you're welcome to log off.